Okay, how many people, let's see here, how many people when's the last time you heard about acid rain? Wow, that's a blast from the past, right? Acid rain. Hmm, what happened to acid rain? What was it and what happened to it? Why don't we talk about that anymore? What inspired this is somebody online was in a probably a public post on about electric cars or something totally unrelated, was trying to create this illusion that global climate change, as a result of the greenhouse effect, is nothing more than the latest pop culture swindle to get people all excited over nothing, and it's just like acid rain. Whatever happened to acid rain? Nobody talks about that anymore. That was such a big problem. Well, the person was being very typical for that kind of a commentary. But really, why don't we hear about acid rain anymore? What happened to it? Well, the easy, quick, simple answer is we fixed it. We figured out how to solve the problem. And we managed to make it go away in several different ways. This really plays into the role of government in dealing with environmental issues. People don't like environmental issues because they see it as a way for government to shimmy its way into people's business. Okay, but the fact of the matter is, this is no different than if you had a neighbor who was burning tires in his backyard. It's his private property, right? Your neighbor is on their private property and they have bonfires with rubber tires and the wind is blowing the smoke into your house. And if you go confront the neighbor basically tells you to F off and puts his middle fingers in the air and tells you to get off his property or he'll shoot you. What recourse do you have? Take that concept and make it as big as the world. Make it as big as a country. This is the kind of problem that we deal with environmental issues, when there's pollution, when there's waste being deposited into public atmospheres and waterways and things like that. And then acid rain was a really good example and how we are able to deal with the problem. Now, the issue of acid rain is very similar chemically to the issue of global climate change, although the product that we're dealing with is much shorter lived and much less fundamental to the operation of the equipment, whether it be a power plant or a vehicle or a ship or something that's burning fuel. Okay, so what was going on was fuels like oil, particularly heavy oil, crude oil, and coal contain sulfur naturally. They're natural products that come out of the ground. There's all sorts of minerals mixed in there, and some of those minerals have sulfur, and when you burn that at high temperature, the sulfur is oxidized to sulfur dioxide, which is a gas. Now you've got a gas that's going to leave your combustion system, and it's going to turn into a atmospheric pollutant. It's going to go into the air and go someplace. All right. So whenever you don't have that much coal being burned or that much oil being burned around the world, like we kind of did up until the Industrial Revolution, it's not a big problem. The environment can absorb that, and it doesn't cause many issues. But then once you start doing things like building gigantic power plants that burn tens of thousands of tons of coal every single day, and repeating that all over the place, now the problem has become such that the environment can't just absorb it and neutralize it, and lakes and rivers and streams and the soil and everything is becoming acidified because it's being inundated with sulfuric acid. which comes from water in the atmosphere, rain, reacting with that sulfur dioxide gas. So your typical coal-fired power plant, big one, like say 2,000 megawatt power plant, burns somewhere around 10 to 20,000 tons of coal every single day. That's a fact that I don't think is really pushed hard enough when we talk about this energy issue, this energy transition issue. People like to talk about how many solar panels and wind turbines you need to replace a coal-fired power plant, but they seem to neglect the coal in and of itself. And that one of those power plants burns millions of tons of fuel every single year. So just in one day, if you were burning 20,000 tons of coal, and that coal has a sulfur content of 2% by weight, you're creating 400 tons of sulfur emissions. When you convert it to sulfur dioxide, you basically double the weight. SO2, 2 oxygens, 1 sulfur, right? You basically double the weight, and it becomes 400, or not 400, it becomes 800 tons of sulfur dioxide from one power plant every single day. Repeat it today, and tomorrow, the next day, over and over and over again. And we have hundreds of these power plants. You can see how this much sulfur dioxide starts to become an issue when you spread it out over a wide geographical area. So what happened was governments basically said, all right, we got to figure out how to deal with this problem, because industry's not going to do it. What incentive does industry have to reduce its sulfur dioxide emissions? Zero. Right? There's no financial penalty for putting things into the atmosphere. At least there wasn't back then. And it would create extra investment and extra work and extra hassle to go after technology to control the emissions. So basically, this is a problem where we have a tragedy of the commons, where you've got this public, this public airspace that everybody is breathing and living within, and you've got individual entities who are using that as a giant toilet. Okay? It's like peeing in the proverbial public pool. That's a lot of peas, right? Peeing in the pool. When you can use the atmosphere as a waste can for your unwanted products. So governments basically stepped in and they said, all right, we need to phase out the emission of sulfur dioxide. Nitrogen oxides, or NOx, are also part of acid rain, but I'm going to focus on sulfur just to save time. And sulfur is also the bigger contributor. So the sulfur was coming from coal-fired power plants. Those were the biggest emitters. They were the largest sources. It was the easiest thing to go after because it was all concentrated mostly in a few hundred sites. And these sites all had permits to emit air pollution. So it's like, all right, guys, if you want to build another power plant, you need to either install technology to collect the sulfur dioxide before it goes into the atmosphere, or you need to burn fuel that has less sulfur in it so that we're not putting so much sulfur into the atmosphere. So they basically said, the companies, utilities were like, well, we don't want to invest money into this because this is very expensive. This is called flue gas desulfurization. It's really all it is. It's acid-based chemistry. You react the sulfur dioxide with water, you create a solution, then you can react that with limestone, which is a base, and it reacts and it forms calcium sulfite, which then you can convert into calcium sulfate, which is gypsum, like what's in the walls of your house, gypsum, that they could sell actually as a raw material, although the value of the gypsum was fairly low. And this whole system here, because the flue gas volumes of a power plant are huge, very, very big, we're talking million cubic feet per minute or something like that, this vessel had to be enormous. And it required retrofitting all these fans and various pieces of equipment. So they could expect to spend a lot of money. So instead of spending all that money, we went and we said, okay, we're going to burn coal that has less sulfur in it so we can meet the standards at the time. So Wyoming, the state of Wyoming, has lots of coal and it's very low in sulfur. It's called Powder River Basin coal. Utilities basically went out there and this is where we're going to buy our fuel from. So the transportation cost, even way out to the East Coast, was such that it was cheaper for them to buy the coal in Powder River Basin, ship it all the way out here to the East Coast or to the South, than to install this equipment. The problem with that is that affected the coal industry. It basically shifted the power of the coal industry to Wyoming, and all these mines in the East were negatively impacted, and the government was accused of playing favorites, and organized labor was involved because the eastern mines were more labor intensive, and the government basically said, okay, we're going to have to change the regulation to mandate flue gas desulfurization on all power plants. And if you're grandfathered in and you don't have it, then you're going to have to buy emissions allowances for sulfur dioxide. So they basically set up a marketplace where power plants that were cleaner could sell allowances to power plants that were not equipped with this technology to make the economics more favorable to the ones that had this equipment. And the market is beyond what I want to talk about here, but basically what it did is it drove plants to install this equipment. The idea was to kind of force them to go in that direction. There's some theories that it kind of dragged out the life of really old power plants, like pre-Clean Air Act. But it's beyond our conversation. Basically here we had this, and over time, over the 1990s and the 2000s, power plants added this equipment, and all of a sudden, they weren't emitting all this sulfur anymore. Right? They were removing usually it was 90% or better emissions control. So power plant sulfur went away because of this. Not only that, but then when the 2010s arrived, the price of natural gas dropped drastically in the US, and all of a sudden it became cheaper to use natural gas to generate electricity than to use coal. Natural gas was easier. It was just less of a pain in the ass. You think about the material handling requirements for it. The plants were more efficient. They required less people. It was just a game changer. And coal went from 52% or so power generation in the 2000s down to like the 20% range today. Now today, probably starting around 2017, coal is also being negatively impacted by renewable energy, wind energy and solar energy, which provide, renewable energy is wind, solar, hydropower, geothermal. Most of it is wind, hydropower, solar. And those sources today are providing more electricity than coal is. So we reduced the emissions by burning less coal with sulfur in it. We reduced the emissions by installing equipment that controlled the sulfur from being emitted from the plant in the first place. We controlled the emissions by using natural gas and renewable energy instead of coal. So, what else changed here? We also were emitting sulfur from vehicles, particularly shipping, heavy shipping, and diesel fuel. So diesel fuel up until the 2000s, late 2000s, had a pretty good amount of sulfur in it. When they would refine crude oil, there's naturally sulfur present in crude oil. That sulfur had to go someplace, and when they make gasoline, basically it would push the sulfur down to the heavier fractions of crude oil, and it would end up in the residual fuel oil. It would end up in the diesel fuel. And the regulations were like, we're getting a lot of sulfur dioxide emissions from diesel fuel, so what we're going to do is we're going to mandate the oil refineries to remove that sulfur at the refinery. So they came up with a process to desulfurize the oil, desulfurize the fuel. So when you buy diesel fuel, it doesn't have the sulfur in it. The standard now is 15 parts per million or less sulfur in diesel fuel. Whereas in the past it was 500, and I think it was even higher than that before. So all that fuel that was being burned with sulfur, we don't have sulfur in it anymore. So diesel vehicles are no longer emitting appreciable quantities of sulfur dioxide. Even in heavy shipping, a lot of ships have moved to lower, lighter fuel oils like distillate fuel oil that don't have the sulfur. Many places have required them to burn lower sulfur fuel. It isn't as big of a problem out on the open ocean as it is in near land, because when you're out in the middle of the Atlantic Ocean and you're emitting some sulfur dioxide from a ship, the ocean's very big, and we're still at the point where that can be absorbed adequately without a significant impact on things. But in port, you don't want to be emitting the sulfur dioxide because that's going to go over land. So by eliminating the sulfur that's in the diesel fuel and reducing the emissions from shipping, reducing the emissions from burning residual fuel oil in things like power plants, which we rarely ever do anymore, we've gotten rid of the sulfur. And acid rain has ceased to be a problem in any appreciable amount. So that's kind of the story. It's a success story of the environment. So anybody says that acid rain was just this big idea that fell out of fashion as a sky is falling concept doesn't know the history, and that's it.